My name's Ed Leafe. Have some contact information there if you want. Just ed.leafe@Rackspace or ed@openstack.org. Those are, also, I'm on Google Plus and Twitter. You can harass me there too. Right now I work as a Python developer for Rackspace. Been there about 5.5 years. And I've worked on OpenStack since it started. Actually, that's incorrect. I worked on it before it was OpenStack because I was on the Swift team while it was still our proprietary software, and then before we released it. So this is one of my proudest bits of swag. I don't know if you can see it on there, but OpenStack founder backpack. It's a rare commodity. And currently I work on maintaining pyrax, which is an SDK for OpenStack-based clouds. And we'll be using that today. But what I wanted to talk about was a common situation for a lot of people. You know, you get some great idea, you create some really cool, interesting application that you're going to change the world and hopefully make you a lot of money too and all that. But you have a problem, is that you got to let people have access to it. So you've got to start dealing with servers that will allow people to access your app. So first thing you do is you find like a spare box or something sitting around. Maybe get a domain name and point it to your box, and the internet starts banging away on it. Now, I did say it was an awesome app, so very soon that app server is going to start to fail under the load because all these people are using your great app. So you come up with something this is like the most basic structure. You put a load balancer and then copies of your servers behind it. And the good thing about this is it lets you scale this horizontally. As you get more and more traffic, you can just throw more and more servers on there. One of the problems with something like this, though, is keeping all those app servers in sync, making sure that they all have the same version of everything, they have the same software running on it, and when they're upgraded, they're all upgraded identically so that you don't have inconsistencies in your application. So we're going to talk a little bit about that later on. But all of this involves hardware. You know, you're getting boxes, you're cabling them together, you're doing all that, you know, all that messy stuff, you know. That's why I'm a software developer. I don't really care for. That's so old school. They're like classic. Yeah, not exactly state of the art. But you know, I guess that's my mental picture. You know, I was wondering, you know, how many software developers does it take to change a light bulb?
None. That's a hardware problem.
Very good. It's a hardware problem. So I don't like dealing with hardware because usually when I do, I have this vision of how I'm going to have everything set up and all nicely linked together and all that, and I end up with something that usually looks like that.
So before was Rackspace infrastructure,
Yeah. Somebody said, "Oh, is that what a Rackspace data center looks like?" No. All right. So where this is all leading to is the cloud. I mean, it's a great buzzword, it's thrown around a lot, but one of the nice things about the cloud is that it lets you avoid dealing with all that hardware mess. So whether you have a full data center like Rackspace or you have a couple of your own servers sitting, you know, in a server room at your company, the thing about when you're working with cloud software is you set up, configure, deploy all your hardware in advance, and then you just provision the resources as you need them. And this way then it's all done through software, but what's more important about, you know, avoiding that is that you can do it programmatically, that you don't even need to have a human being doing all this stuff for you. You know, this can all be done automatically. And the reason this is possible is through APIs. APIs are great. They let you do just about anything you want to do. But the problem is as flexible and powerful as they can also be kind of a pain to use a lot of the time. I do have, if you want to see some of the APIs that run under the hood for pyrax, we have both the Rackspace docs and the OpenStack docs. And those are available online, and you can see all the things that are available to you. So I figured let me give you a little example of what it would take to use an API to get a list of your servers on Rackspace Cloud. Now, I'm just assuming here you knew that URI, that you magically knew that. And you just use URL lib to open that up and print the response, right? Couldn't be easier. Oh, we forgot something. Yeah, not anybody can just go and take a look at your servers. You got to show who you are. So yeah, auth is trivial. Let's just handle that. You know, this is very basic. You're just
Using basic auth, too.
yeah. You're just passing in your credentials, you know, setting all the headers and handling the response.
In a non-SSL connection, too.
There you go.
We're excited about that opportunity, dude.
Yeah. Oh, but you're not done yet. Now you got to get your credentials back, your token, when it expires, your tenant ID, all that information, and save that, because you're going to need that for every single request you use after that. And not only do you get that token information back, you also get the service catalog back. Remember I said you magically knew that API endpoint for the servers? Well, it's not known in advance. You get that from the service catalog. And that's what the service catalog looks like. Yeah. Yeah. What the service catalog does is it gives you a list of every service that is available to you. Depending on your auth levels and credentials and all that, you can have many services, just a few. It could be confined to certain regions and all that. But that will tell you what you're able to access based on the credentials that you supplied. And a lot of the services are region specific. So if you need that, each one will have a different endpoint. So you can get that from the service catalog. And this is just the service catalog for the compute service. And this is an old slide back when we only had 2 regions for Rackspace in the US. We had, they go by airport code. So we had the DFW region for our data center near Dallas, and then our Chicago data center. We now have, in addition to those 2, we have one in Virginia, London, Sydney, and Hong Kong, and probably more to come.
Excuse me, that's JSON? That looks like some Pythonized JSON.
It's basically, yeah, dictionary, I think. It might have been already converted back to dictionary. Yeah, it's Pythonized because you got the U's in there. Right. So that's basically when you use JSON to load the service catalog, you get back from the auth request. Then that's what's converted from there. And then it's just a trivial thing to get the URI to find the servers for a particular region. And then now you create the request. Oh, don't forget to add your auth headers on your HTTP headers. Now you can make the request, and you get that back. Okay, and that's only if you have just 2 servers. So that's what one server looks like. And there's a lot of information about it. This is all relevant information for your server. But basically, the things in yellow are the things that, like the 99% use case that you have. Basically, you want to know its ID, its IP addresses, when it was created, what its status is. Those are the things that you really care about most of the time. All the other stuff you might use once in a while. But so, you know, the purpose of showing you all this is that you're Python developers. You want to code in Python. You don't want to have to deal with this stuff all the time. The other thing is that what will happen is you'll do this once for the first call. Now you want to do another API call. And you start to do this all over again. You go, wait a second. I need to refactor this out. I know, I'll make a class just for handling all this stuff that'll handle all the auth for me, that'll parse the service catalog for me, that'll do all this stuff for me. Now I can just make calls to that particular class to...
Yes, you've done that.
Well, that's the point, yeah, is that everyone has done that, I think, at some point, and so why would you want to reinvent the wheel? Because like I just have all the things in there that you end up doing for each request. So that's where SDKs come in, and that's sort of where this is all leading. And the whole point of SDKs is to take care of all that tedium for you, to handle that and let you focus on what you actually want to do in your code. So this brings us to pyrax. Originally it was a Rackspace specific module, but we've now expanded it to work with all of OpenStack. So we might be changing the name in the future. We're not sure. It sounds too Rackspacey, so. But for now, it's pyrax. And of course, it's open source. So if you go to the Rackspace organization on GitHub, you can see it there. You can fork it. You can pull requests, lodge issues, whatever. And it is fully supported. So even though I'm the one writing and maintaining it now, if I get hit by a bus or meet some rich, beautiful woman who wants to just fly me around the world and take care of me, and I decide that, well, maybe writing code isn't what I want to do all day long, it's not going to be abandonware. It's going to still be around. Rackspace will still support it. So, enough talk. If you want to see some code, before I do that, what I want to do is run a little script. All right, I have this script that's going to go through, and while it's running, it takes a while to run. I mean, cloud, you think of it as instant, but it does take a few minutes to get instances provisioned and set up and configured. So what I'm going to do is just start that running, make sure my connection is good. Okay, that's running. And I'll show you what I'm doing in there. First off is that authentication part. Now, there's 3 ways you can authenticate. The preferred way is to set up your credentials in the keychain for your operating system, and then you can just call keyring auth. And then that way your password and keys and all that are never stored in plain text anywhere on your disk. For development and for, just for simple situations, sometimes you want to put those credentials in a file on your disk somewhere. And so you just pass in the path to that to set credential file. Or if you're really just hacking, you can pass the credentials directly to set credentials. These 3 lines here all do exactly the same thing, just give you a different way of doing it. And when you do that, when you call that, what it'll do is it'll authenticate, it'll grab the service catalog, populate an identity object with all that information, and set up client objects that then you can then direct your requests to. Do you have a question?
Yeah, you haven't even started talking to your cloud provider yet. How does keyring auth know which key to go after?
We'll get to that. Very good question. If you don't have that set up, you do have to. There are some settings that you have to set. You can either set them in a configuration file or you can do them manually. But I'll show you that in just one second. So that's what the credentials look like. It's just a standard configuration file. For straight OpenStack using Keystone, you need the tenant ID along with your username and password. For Rackspace authentication, you just have your username and API key. Either one of those will be what you have in there. This is the configuration file. It's also a standard config file format. And each section in there defines a different environment. And then you can just switch environments. I do it all the time when I'm testing. The one up in the top is my default when I was testing the Sydney data center. And I can set my keyring username, and then it'll use that to pull my credentials out of the keychain. The first one, though, identity type, defines how you're going to authenticate, which plugin you're going to use. So the Rackspace auth is different because we have a whole different auth system. That's the nice thing about OpenStack is it allows you to pick and choose the parts you want. So if you want to swap out your own local auth system, something, let's say, based on LDAP or EDR or something like that, you can do that. You don't have to use Keystone's auth. So we have our own system that we use, and there's other things you can do like debug. If you set that to true, when you're doing all your calls, it'll print out every request and response and fill up your screen very quickly. There's one on the bottom, the DevStack one. If you're not familiar with DevStack, it's basically a one program installer for OpenStack, and it'll create an OpenStack installation that then you can mess around with. It's not meant for production, it's meant for development, hence the name. And so that's actually running on a VM in the Rackspace Cloud, so I have little inception going on here. I have OpenStack running inside of OpenStack and turtles all the way down. But there, you see, I have to specify the auth endpoint there, because otherwise it wouldn't know where to go to authenticate. So when I'm running against DevStack, it'll hit against there. It'll use that tenant name and ID. And so that's how you set that up. You can also, there are also individual methods for setting those values, so you could put that programmatically in your code. I think config files just make your life a lot easier for stuff like this. It doesn't change every iteration. Got a question?
Yeah, so is there a special case where you would want to change the user agent? Like that option, custom user agent?
Yeah. Yeah, some people have requested that they want their user agent to appear, so you can customize that. So if you have your own OpenStack deployment and you want to see who's hitting it, you can put your own application name in there to then do analytics on who's requesting what. And so it'll just add that to the standard pyrax version, whatever. So. Okay, now the other thing is like when you authenticate, it'll set up client objects that then you direct your requests to. So for servers, files, load balancer, all those, I usually in my code just have abbreviations for them. One, I'm lazy, and two, I just think it makes the code a little clearer. Some people prefer spelling it all out. Like I said, I'm lazy. Okay, so here's what some of the code looks like. For creating a database, right now, Rackspace Cloud Databases only supports MySQL instances. They are working on Postgres and MongoDB. I do not have estimated dates for those being released, but they are in the works. So, but when you do this, you call clouddatabases.create. You pass in a name for this instance. Flavor is one of those OpenStack conventions that I don't like very much, but it basically is a RAM disk combination. So I just have the minimal one there. Volumes is how big in gigabytes do you want the storage for that? You can always make it bigger, you can't shrink it. So what this will do is create an instance that has MySQL installed on it. Now this is the critical thing, wait for build. When you create a resource, it's all done asynchronously. You put in your request, it gives you back an ID and says, I'll go make that for you. So you can't really act on that until it's fully built. And so what'll happen is this utility function will go and take that. The verbose just will print out, and that's what's going on in this. You can see this current value. If you look up at the top, you can kind of see where it was, status was build, and it finally went to active. Took a little over 3 minutes, and so that database instance was created. So then once that's now in an active state, I can then go on from there to create a database within that instance, giving it a name, and creating a user, and specifying the name, password, and one or more databases that they will have access to.
My script appears to be synchronous because you have to wait for build.
Right.
So my script is easy to write.
Yeah, so you get very good segue there. One of the nice things about wait for build is it takes an optional callback parameter. So what you can do is I could put the calls for the create database, create user in a separate little method and pass that as the callback. And then this will, the wait for build really won't wait. It'll just call back to that method when it finally is active. But your code will then go on without blocking there. So, yeah.
And what you're doing in that first line
Right. It's sort of an unfortunate clash of nomenclature that we think of it as a database, and then within there we have individual databases. So it's actually a cloud database instance, which is why I called it DB instance, just to keep it clear in my head. But like, yeah, if you install MySQL on your machine, you can create multiple databases within that installation. So that's what that is. So basically, it's a very focused virtual machine running MySQL and basically nothing else. So, any other questions? Yeah.
Does that depend on particular images being defined? Would that be a Rackspace specific thing that wouldn't work on a general OpenStack cloud? Or?
Well, this is the Rackspace cloud databases. OpenStack has the Trove project, which this is based on. So yeah, it should work with that. This is based on the same code as Trove, so it should be compatible. Is there anything else? Yeah.
The DevStack install script has a switch where you can have the backend services all be Postgres. You're saying that doesn't actually work, or I haven't tried it yet. I'm just wondering.
Okay, that's a little what it's doing is it's OpenStack needs a database to store information about what it's managing. You know, if you think of cloud software like OpenStack, it's managing a lot of information about where things are on different host machines so that you don't have to. You just say, give me this server, and it knows where to look on what machine and how to do the networking for all those things. It has to keep track of that somehow. So the original guys that worked on OpenStack were all ex-MySQL guys, which is why that was sort of the default. And then a lot of people who prefer Postgres then built in the option to, if you have Postgres on that machine, to use that as your data store for OpenStack. This is something different. This is like one level down. This is on the user level, creating a resource that happens to be a database instance.
And so what is the holdup for having that exposed as Postgres, for example?
I'm sorry, I have crappy hearing, so I guess.
Just wondering what the barrier is to, you said this is MySQL is ready now, Postgres perhaps is,
Yeah.
What is the barrier to exposing that as a service?
To be honest, I don't really know. I just know that they're ramping up for that. MySQL was the first one. They wanted to get that out quickly. Now they're adding Postgres. I don't expect it to be like a huge delay. It's just one thing at a time, I think.
I think the database runs on actual physical hardware, not a virtual machine.
Does it?
Yeah, I think that's what the difference is.
Yeah, I'm not sure about that. The comment was that the database ran on actual hardware and not on a virtual machine. That's one of the new things that they're adding with OpenStack is OpenStack on bare metal, where you're provisioning bare metal. And I like the project name is ironic. So yeah.
As far as I know, it's a container.
Say that again?
It's a container.
Yeah. Containers, okay.
Can you have like post install hooks for like once a VM is created, you run special, like your own special set of commands or whatnot?
So you're talking something like a chef recipe or something?
Not necessarily even shell scripts. Like you can install Postgres straight out of like configure, make, and things like that.
Yeah, there's a project in OpenStack called Heat, which is like an orchestration layer that could be used for that. There are, the products like Chef or Ansible or any of those other individual machine configurations that you could use. So, and you could have like that wait for build when you create your servers could then go and call your script to go and configure it the way you want. So that's another option. Okay, so the next thing we want to do is, if you remember that diagram of our setup, we have all those servers behind a load balancer. They don't need to be on the public internet. You actually don't want them on the public internet. So this is how you define a software-defined LAN. You just define a name, a CIDR, and you call cloudnetworks.create, pass those in, and you have a software-defined LAN that you can then use for your machines.
That sets the security profiles and all of that. By isolated, you mean
Isolated, it's a non-routable. Yeah, so you know, it's a 192 network. So the other thing that I'm showing here is how to define key pairs. So if you want to create a server and you don't want to have a plain text password as your access to it, you can define a key pair in cloud servers that'll be stored on the cloud. So I'm just reading in my public key and storing it up there. You only have to do that once. And then once it's up there, every time you create a server, you just pass in, oh, sorry about that. My trackpad is a little weird, and it's been acting up. And it manually seems to do things. I think we have, yeah. Yeah, come on, go back. There we go. I think it was that spooky debugging. I think I need to talk to them about an exorcism or something. But anyways, what this does is it defines a key pair named MacBook, and I can then create it, and then when the servers are there, I can shell right into them and without having to worry about passwords. All right, this is the one it wanted to show. This is where we actually create the servers. Now, when I showed you that one picture of all the, the application servers, the problem was getting them all to be identical. And so you could run something like Chef or Ansible to configure them there. But what is probably preferable is I created one, created one server, did all the system upgrades and all that to get it set, installed. I think on this one it was Apache, got it configured, installed my app and all its dependencies. The app is it's a simple Flask app that just spits back the local IP address and the date and time, just so you know which machine is handling it. But I got that so that it's all working and ready to go. And then what I did is I took a snapshot of that server and created an image. And when you create a server, you can use any of the stock images that your provider has available. And these are usually like Ubuntu, CentOS, or any of the other distributions, or Windows Server distributions. And so you get a plain vanilla installation, sort of like if you had the ISO image that you get from them, and you create a server based on that. This way you can create a server with a pre-configured image. So when those servers that are created will be identical to the server you configured already and took the snapshot of. So it makes duplicating your servers that much easier. So you can be guaranteed that they're the same. So for this demo, I just had the ID of that image and hard-coded that in there. All right, I want it on the service net, so I just defined the networks. And here's the code that actually creates the server. I gave it a name, PyTexas serve1, passed in the app image, flavor again, key name MacBook, so that it'll have the SSH key installed in there automatically, and the networks. And I wanted to create two servers, so I did the same thing. The only difference between them is the name, so just so I can keep track of them. And then I did wait for build on those. Most likely, by the time server 1 is built, server 2 will either be fully built or really close. So those should finish just about the same time. So now I'm going to create the load balancer. First thing I need to do is get the addresses, the private addresses of the two servers I just created. Get those. Define nodes. Load balancers think in terms of nodes because they don't really know what they're balancing. There could be other load balancers. There could be other devices. But they just need the address, port, and whether or not they're enabled. So you can actually define a node, put it behind the load balancer, and it won't actually get served any requests until you're ready for it. So the other thing in there is the wait. So if you have typically servers that have different capabilities, you can give them different weights, and they will get proportional amounts of the requests. You can also do that for if you're doing like A/B testing or something like that. You can do one other server with a different weight and monitor its responses. And then you just define the virtual IP type. Not much to this. If you want it on the public internet, it's public. Otherwise, it's private. And here's where you actually create the load balancer. So I just pass in the information about it, that this is going to balance HTTP requests. I'm going to pass in the list of nodes that I created, the virtual IP I created, and what algorithm it uses. The constants are listed in the docs. This is a round robin that'll alternate the load and according to the weights that are assigned to the nodes. There's one other thing I wanted to mention. If you notice, nodes, I'm passing in a list of nodes, whereas virtual IPs, I'm passing in a single value. One of the things I did in pyrax, there are a lot of cases where a parameter can either be a single item or a list of those types of items. And so in all of those cases, you don't have to always remember which to cast it into. If it can take either, you can pass either, and the SDK will handle that for you. Finally, you wait for that to build, and then you grab its address. Now you have a public IP address that will be able to serve up your application, but to make it easier, you want to configure the DNS. So I have the domain name pyraxdemo.com, and with that, I can define a domain using the DNS service, the cloud DNS service that we have. And you just pass in the basic information for that, and it'll create the domain information. And then I create an A record for it that points to my load balancer and add that. And that's all it takes to configure your DNS. And you're ready to go. Let's see how this is going. Okay. Anyone have a browser open? Okay. You have a couple of, first off, server 1 and 2, you can see they have 10 dot addresses. They're not routable. They're not on the public internet. But the load balancer address is there. If you type in that address, you should get a web page that has one of these two addresses, either the 198 or the 185. Anyone get the 198? Anyone get the 185? Okay. So you can see it's actually balancing. If you refresh, sometimes there's caching, so you might get the same one over and over again. Anyone want to type in pyraxdemo.com and see if the DNS is propagated yet? Is it working? And you're getting one of those two machines? Okay, so we just did all this, while I was gabbing about the code. Now, if you notice the bottom there, it says ready to add a third server. So I'll just start that going while we're talking. And it's going to actually create a new server based on the other ones. Well, it's taking that image, deploying it to, figuring out a host machine to put it on, deploying it to there, configuring the networking, getting it all set up. So they generally take anywhere from 3 to 6 minutes for a server to be created. I'm still not 100% sure of why sometimes it's really fast and other times it's really slow. Could be load on the machines. You got any idea?
It's load and how much free space is available in the various clusters. Sometimes it has to try one part of the cluster and then another, depending on
Yeah.
whether or not it can slot in an instance.
So a lot of it is basically load and availability and things like that. That'll control it.
Yeah, it's resource management. It's
Mhm.
just like, sometimes allocating a chunk of memory is
Yeah.
depends on how fragmented.
Okay. But anyway, this is like the situation where we have it set up with 2. We're seeing that there's a lot of traffic on those, so we want to add another node. So it's the same code as before, except I just named it serve 3. Wait for that to be built, grab its IP address and define a node based on it, and then just add that node to the load balancer. And the other way, the reverse, if you had a whole bunch of servers and your traffic went down, you can just delete the node and then just delete the server, and they're gone. And nice thing is you don't pay for them after that. So this good thing about like cloud resources is you only pay for what you use. If you're not using it, delete it. And if you need it later, just recreate another one. You know, they're ephemeral, you know, if you need them to be. Anyway, let's see if that's there. Let me see. That's still building. Okay, I have the slides and that script that's running in the background up on GitHub. So if you want to grab that and play with it and have fun, they're up there. So any other questions? How are we doing on time? God, I had to do this talk in Toronto last week, and they wanted me to squish it down into like 15 minutes. And I was up there talking like this, and then there you go, and then you go, this. This is a lot nicer. Yeah.
You mentioned on the database creation slide that the size of the database you can increase but not decrease.
Yeah.
That happens magically, or?
There's a resize method on the database instance, and what you can do is just pass in a new value in gigabytes, and it'll expand that volume. Once it's expanded, though, you can't really shrink without doing some truncation. So if you try and do that, you'll get an exception. So yeah.
So for a private cloud where you may be more likely to be running up against your quota limits, what kind of the UI when you say create and it comes back and tells you you're out of quota, you don't have room?
Oh, so for a private cloud, how would you monitor the state of your cloud?
Well, more I'm looking at something where we'll be offloading some stuff to an OpenStack instance, but we suspect that won't have capacity for everything we want to do with it, so we'll need to. In general, what happens when something blows the quota? Yeah.
Yeah.
You've hit your limits, and it's saying no, you can't create one of those. You don't have room.
All right, so there's two things. There's the system capacity and your individual limits. Yeah, there are functions, I didn't show them in here, but there are methods to get your limits, and you can see what your maximum allowed is, how much you've used, and what the period of time before that limit resets. So yeah, those are all available in the API and also in pyrax.
I guess I'm talking about the fact of you have stuff up, it's all currently running, and you go to create something that doesn't appear.
So the system is out of capacity, like the whole cloud deployment is out of capacity?
No, even you're just at your quota limit.
Yeah.
What's pyrax?
Oh, you'll get I think a quota limit exceeded exception. I'm not sure the exact name of it, but you get an exception that will basically say what it is that you did that caused it to fail. In the case of exceeding your limits, then it'll be something that will give that, and it'll have the information in there what your limits are.